Hi, I am an IB math teacher, and today I want to show you an IA that I wrote myself. I don't mean to say that it's perfect. I don't know if it would get 20 marks. That's not the point. I just wrote it because it's fun, and I think that I can make some comments around it in terms of the rubrics. But again, I wasn't trying to make it perfect. I wasn't trying to get all points and everything. And I also don't think that you should do that. Of course, do your best, keep the rubrics in mind, but I really don't think that you need to get a perfect score on your IA anyway. It's just 20% of your grade, and the majority of your points are going to come from the papers anyway. So the first thing that I want to say here is that yes, I wrote about a game, Clash Royale. A lot of my students also like to write about games. But the thing that I think is different between what I did and my students tend to do when they write about games that they play is that they spend a long time describing the game and talking about how every single aspect of the game works and why they love this game. And I think that on some level, they think that that's going to show their personal engagement, but that is not how personal engagement works. So in my IA, this first paragraph here is really all that I had to say about the game. I said it's one player against one other player. I don't even talk about cards at all or the mechanics of the game. And I do say that there are no ties in the game because that is going to be important mathematically for my IA, because I'm going to be talking about winning and losing. And I just thought that I would mention early on that there is no third option. So it really is 50-50. Either you win or you lose. The thing that I did describe was the challenge. A challenge is a sequence of games that ends when you lose 3 times or win 12 times. That's the thing that I'm going to be studying in the IA. So of course I needed to describe it, but it's just one sentence, okay? Don't go on and on talking about the game. So then I have a second paragraph talking about my probability of winning a given match. Is it 0.5? Is it less? Is it more? Because this is really the question that I'm going to be talking about. And then I say something about how the expected number of wins in a challenge should be 3, because the challenge wins if you lose 3. And then if it's 50-50, you lose 3, maybe you win 3. So that's 3. I know it's a very weak argument. I say a little bit more about it in the next paragraph, but the point of this weak argument is not that I'm trying to convince my reader that it's strong. It's just a starting point for the actual calculation that I'm going to do next. And then I immediately go on to say that the aim of the IA is going to be to properly calculate the distribution and expected number of wins in a challenge. So why did I do this weak argument before? It's just so that I have a notion of what to compare it to when I find the actual result later on, because analyzing your results and reflecting upon your results is something that's in the rubric, right? You're supposed to not just calculate an expected number, which is what I'm going to do, but also that number that you find, it needs to have meaning to you. Does it match what I thought was going to happen here? Why or why not? And in order to do that, you need to be expected something in the beginning, right? So that's what this thing where I think it should be 3 comes along, because it's not enough that you have an initial notion in your mind to compare your results to. You have to put it on the paper so that the reader also knows what's going on. Okay, so with that in mind, let's go on to calculate the expected number of wins in a challenge. Of course, I need to calculate the distribution first, because what is the probability of getting 0 wins, 1 win, 2 wins, and so on? Those are the numbers that I'm going to use to calculate expected value, right? And then I say that I'm going to do that by first writing down a systematic list of all the possible ways that a challenge can go, which is basically what I see in this table here, right? So first of all, you can lose all 3, or you can win 1 and lose 3 in these various ways, and then win 2 and lose 3. Before you start rigorously calculating something, it's okay for you to not know beforehand how you're going to do that. That's actually what the exploration process is about, figuring out how to use the mathematical tools that you've learned in the course, and which of those am I going to be using for this purpose. So it's actually a good thing for you to put a little bit of that process of figuring out into the text of your IA. Of course, you're going to do it, but don't just do it on paper and then write down the finished result. You also don't want to do too much of that, right? You don't want the whole thing to be like, I don't know how to do this. Should I do this? Should I do that? There is an optimal amount of that should be in your IA. I was trying to do it the best way possible, but again, that's a little bit subjective as well. So here is really how I figured out how to do this calculation. When it comes to this point, I already understand what is going on. So first of all of the challenges end in a loss because that's mostly when the game stops. You lose the third time, so that's it. It's over. So the final game in a challenge is just going to be a loss. So I'm assuming that the probability of that is going to be half. And then I have to multiply that half separately from the probability of the other games doing the thing that I want them to do, which is a specific number of wins. So when I want to calculate the probability of one win, the sequence is going to have one win and three losses. So that's 4 games. But the fourth game is not going to be the win. So the win can either be the first, the second, or the third game. Those are all of the possible sequences. So that's that. There are 3 sequences, which becomes the numerator of my fraction here. And the denominator is 16 because if the probability of winning is half, then the probability of losing is also half. Half times half times half times half. And then I do the same thing for 2 wins. In this case, it's 2 wins and 3 losses. So 5 games and the denominator is 32. But the number of sequences in which this happens, well, I've listed them all here in a systematic way, starting with all in which I win the first game, and then the second win is either this one, and this one, and then moving on from that. But I can already see that in a more structured way, which is that I have 4 games, not 5 because the last one is a loss, but I have 4 games out of which 2 need to be a win. So that sounds very much like binomial distribution. It is a repeated trial of playing a game. You're repeating it 4 times, and the probability of winning is a half, and you want to ask for the probability of the number of wins being 2. And I do mention that in the IAs sometime later on, but that's not the way that I chose to do the calculation here, because it would be a different binomial distribution all the time, like 1 for 2 wins, 1 for 3 wins, and then I would need to create all these letters to call the variables that have these distributions. It would be confusing, and also it feels more natural to me to think about this in terms of the binomial numbers, which is in how many ways can I choose 2 out of 4 things? This is actually my favorite notation for binomial numbers, 4 choose 2. I realized that the notation in the formula booklet is different. They write it like this, with the 4 on the top left and a 2 on the bottom right. As for my calculator, this looks in the screen like 4 choose 2 with the 4 on the bottom left, but I couldn't get Google Docs to write down either of those things. So I went with the top right. There are a lot of different notations that people use for the binomial numbers, as we've just talked about, and I am choosing one that is maybe not the most common one. So I think it's an important thing that I mention that. I say it right here. The number of possible sequences following those requirements is this, where by this notation, I mean that. And then I use the formula for the binomial numbers to express the fact that this is what I'm talking about. Notice how at this point of the paragraph, the spacing between the lines is getting all wacky. And maybe this would be mitigated if I was doing it double-spaced, if I was using a different font or whatever. But actually what I want to say is that this is okay, all right? Don't worry if your line spacing in the middle of a paragraph is not constant, because it's more important to have the equations be readable. And it's very important that the equations come as part of the flow of the text. So if you read it here, the total number of sequences of n plus 3 better results is 2 to the power of n plus 3, so that the probability is equal to that, which matches the examples in the table. So this is a sentence. It's a sentence that you read with words. So the equations are not separate things that you throw on the page separately from the text. They are part of the story that you're telling, and they should flow as you read like that. Every time that I have either subscripts or a fraction, the font becomes really, really small within those things. So what I've done is to increase the font. I think the original font size in the paragraph itself is 11. And then when I have a fraction or the and choose R, I've turned it into 16. But here's where I'm really proud of what I've done in terms of mathematical communication in this one. If you just use one equation to type the probability of x equals n equals this fraction, and then you make the font for that equation 16, the left-hand side is going to look huge. The p of x equals n. That's going to be really big because it shouldn't be font 16. It should be font 11 like the surrounding text. So I've actually done two equations here. The first equation is just this with font 11, and then there's a second equation with font 16 right next to it. So visually they look like they're all the same size. This is really pretty. It's a detail, but I think it really makes it look pretty. It's good for mathematical communication when things look good. So anyway, obviously the case where the challenge ends with 12 wins is different than all of the other cases because that one doesn't end in a loss. So I also calculated it a little bit differently. But again, I've written two equations so that one of them can be font 11 and the other font 16. But what I wanted to show you here is that because this equation was bigger than the previous ones, I thought that it would look better separated into its own line. I didn't want to put that in the middle of a line of the paragraph. I thought it would look very strange. And that's not because of the spacing between the lines. That would not be different from what happened in the previous paragraph. I just thought that it would increase readability because now you're actually reading a big sentence that is all math symbols. So whenever that happens, I like to put it in its own line. And it is subjective, okay? Sometimes it is your choice whether you're going to do that or not to a particular equation. But the thing that I want to point out the most here is that even if you do that, if you separate it centered in its own line, it is still part of that sentence in that paragraph. So it doesn't change the way you read it. Doing each case separately, we find that the probability is equal to that, period. It also doesn't change the punctuation. That is still part of that sentence we were reading, and the sentence is part of the paragraph, so the punctuation goes right there. In this particular case, the next sentence is starting a new paragraph, but it didn't need to be, okay? This is normal text writing paragraph stuff. If it was the same paragraph, then I just wouldn't have this white space here, and that's fine. So at this point in my IA, I don't need to be listing and counting sequences anymore because I've already done the math. I already know how many there are. It's this probability until n equals 11, and it's this probability for 12 wins. So that is the perfect time to go to technology. Sometimes people think that the more calculations you do by hand without resorting to technology, then the better your grade will be in your IA because you're doing more math. That is not the case, okay? It's actually more like, do you know the correct points to turn to technology? Do you know when it is appropriate? And I think it's very appropriate right now. So I went to Google Sheets. I just chose in this IA to mention which kind of technology I was using at each point. And I even mentioned the commands that I used. Sometimes I tell my students not to do that. So it's kind of weird that I did it. But I think that it was a very small comment. It's not like I'm going on and on about how I know how to use Google Sheets. And also, I thought it was an unusual command. It's not like I am saying, in order to add two cells in Google Sheets, you type equals this, that, which are things that you expect everybody knows. And also in terms of presentation here, notice how I've changed the font to type a command. Also, I forgot to mention, but notice how my table has a title, and then the next page has a figure which also has a title. This could have been a table and a figure separately, but I was just trying to save space. Now, here's a very important comment. Take a look at this table, because I feel like it's so common when students get to this point where they've finally gotten a bunch of numbers to work with. It's just like the numbers are there and then they keep going without even looking at the numbers. You are supposed to analyze your result. You're supposed to look at these numbers and question some things about them just because they are interesting. You want to show that you are interested. It would be so easy to, like, I have the number of wins with their respective probabilities. I said in the aim that I wanted to calculate the expected value. So, well, it's this times this plus this times this, and so on. In the end, there will be a number, which is the expected value, and then I'm done. My IA is finished. And that is a reaction that I get sometimes from my students when I suggest topics such as this one. They go like, well, but then I'm going to calculate the expected value, and that's it. That will be boring. Listen, if you stop after calculating the expected value, then it's boring. But the thing is that you never know what you're going to run into until you actually do the calculation. So I'm talking to you here, and you should have noticed at least two things in this table of numbers that are attracting your attention and that you want to question. So if you haven't done that yet, pause the video and go ahead. Two things that you want to question. One of them is that there are two numbers here which are exactly the same. It's always interesting when something like that happens. Is it a coincidence? Is it not a coincidence? If you don't question it, then you only show that you're not paying attention. And if you're not paying attention, you are not engaged with the topic of your IA, and you can't expect very good marks in rubric C. So in this particular case, I do comment on it after the table, and I just say, oh, well, that's a coincidence. I don't know. I didn't want to think about it too much, but I did mention it, so to show that I noticed it. But the most interesting thing here, for sure, is that the probability of getting 12 wins in the challenge is bigger than the probability of getting 11 wins. How is that possible? 12 wins is more difficult than 11. Of course, I'm going to go into why the numbers are turning up this way. But the point that I'm making here is that you have to question. You can't see something like that in your results and not stop to say, wait a minute, what is going on here? You can see that it's very slightly going up, right? The graph here shows that it's not that much, but still. So I decided to calculate the expected value first before going into all of the interesting things that I was seeing. And then I said, oh, look, it's $2.99. Remember in the beginning, I thought it was 3, so yeah. And then I go ahead and mention that the probability of 12 is bigger than the probability of 11. So I'm putting that on the screen here in case you want to read it. I think I would waste too much time talking about it. But this here is also interesting, okay? And it is true that while I was doing this, I was like, did I make a mistake here? Because that's not making sense, which obviously is a good attitude for you to have in math all the time, right? You're always questioning whether what you're doing is correct, so that you can catch your own mistakes. But also, I wanted to put it in the IA because I wanted to write a sum just to make the mathematical communication a little bit prettier. And by the way, here is one of those large mathematical sentences that I chose to highlight in its own line, but it is part of the sentence that was coming before. Like, it also means that this thing is equal to 1, and then there is a comma here because the sentence goes on after that. So like I was saying, the text is still flowing. The equation is part of the sentence, and the sentence is part of the paragraph, even if you chose to put it in its own line. So when I wrote that down, I was like, hey, this looks like this is a sum with binomial coefficients. This reminds me of Pascal's triangle, and I know that this is absolutely nothing to do with the aim of the investigation, but it was too pretty not to do. I think I may be sacrificing conciseness here. I don't expect that I would necessarily get all 4 points for rubric A, but I did that for a reason, and that felt more important to me than being concise, because in the end, this whole thing is only 12 pages, so I'm fine. And if you don't know what I'm talking about here, this identity about Pascal's triangle, I am probably going to include that in another video later, where I will also talk about like the use of these numbers instead of the binomial distribution. But for now, what caught me wondering here was that what if instead of 11 here, I would had this thing go all the way to infinity? Maybe this extra part here wouldn't happen, and then I would just have one big sum to infinity being equal to 1. How pretty would that be? So I went ahead and I thought about that, found a place to also include a limit, because that also is pretty mathematical notation. And then I went ahead and I proved that it wasn't that difficult. It was just doing the calculation again, but with a large number instead of 12. And I highlighted a sentence here where I say that this argument is actually rigorous. I included that in there because, at least for the high level rubric, there is this word rigorous there that could give you an extra point in rubric E. I am not sure if the way that I wrote it here would actually get that point, because mathematically I've mentioned all of the things that are required for a rigorous proof, but I definitely did not write it down as a rigorous mathematician would. I could have, but I was just doing this for fun. And here's the thing, when you go too far into the rigorousness and then you start writing down math the way that mathematicians do, it can become so boring and dry, and like it takes the life out of it. So I even wrote this down here. I said I'm not going to do that because I like this paragraph. And like I feel that in an IA I can get away with saying something like that. I definitely couldn't get away with it in writing a mathematical paper, because it wouldn't get approved for any journal with that kind of language, which is actually a really sad comment about mathematics. Most of the time you don't get to write in a fun way that reflects how you're feeling about the math, how excited you are about it, and how cool you think it looks, which I think is the reason why I had so much fun writing this down, not going for a perfect score, because I got to write things like cool. And I think that's very fun. As a student writing an IA, I am not really recommending that you write in this way necessarily, because in order to look like the thing that I want it to look, which is this person knows so much math and they're even having fun with it, in order for that to come across in the text, you have to really, really know the math. Okay, so don't try to do this if you are a little bit insecure about what you're doing. It's better to be safe and write in a more conventional way. And then in the next paragraph, I very quickly addressed the other coincidence that I had seen on the table. Actually, it's right here. Because every time you see a coincidence, you kind of have to address it, even if it's just a quick paragraph to say that it's a coincidence. Because if you don't, then it looks like you don't care. So I did the cumulative distribution as well. I don't really know what motivated me to do that, rather than just, this is something that we learn in the course, so I have a distribution, I want to look at the cumulative as well. So when I do that, I found another coincidence, which was a perfect 0.5. Again, this is a coincidence maybe, but it needs to be addressed. In this case, I ended up thinking that it was not just a coincidence. I was able to find an explanation by flipping all the wins and losses in a particular size of sequence. And again, I'm not going to waste too much time talking about it. It's here on the screen if you want to read it. I just want to mention that this is a very common trick, okay, is in math. This is not just a brilliant new idea that came into my mind when I was writing this IA. No, this is definitely something I've seen before. This kind of trick, when you want to prove that something is exactly a half, then you try to pair them somehow to put half of them here and the other half there. When you have your aim of your IA is to calculate the distribution of something, so is the IA finished once you have calculated just that? No, there's more things that you can question. And here's a very specific thing that should come immediately to the mind of all students who are taking the applications course. not necessarily for the analysis and approaches people, but if in your draft feedback your teacher goes ahead and says, listen, you should look into this thing, which is called hypothesis testing, which is part of the syllabus of the other course, then it's actually very good for you to be including something in your IA which wasn't covered in the course, right? It's making it more. You're doing more work, you're more engaged with the content, you're maybe putting more math into it. It's good for several reasons. And of course, for applications students, if you don't do this, it just looks like you don't care, because it is a standard situation for the chi-squared goodness of fit test. You have your expected values. Now you throw some observed values in there and do the test. And again, I'm still putting like very neat titles in all of my tables. I am making sure that my tables don't break to the next page, which is something that is very annoying when I see my students doing that. So in the case of this particular table, I specifically remember shortening the previous paragraph so that this whole table would fit on the bottom of this page. I didn't want it breaking into the next page. It's like the minimum amount of care that you can put into your presentation. If you have a small table breaking into 2 pages for no reason, that looks really bad. So in my case, I was able to do that by shortening the text, but it doesn't have to be that. You can just move the table to be at the top of the next page. The other thing that this table is showing us as for presentation is that this first column that says x equals 0, x equals 1, they're very small things. A lot of students just don't put those into equations because I can easily type x equals 0 without getting into the equation editor. But please don't do that, because the font in the equation editor is slightly different from whatever font you're using outside of it. So it looks sloppy if it's something that is supposed to be mathematical notation and you're not typing it in the equation editor. And notice that this table has a disclaimer underneath it, which is something that you're definitely not going to get the opportunity to do. But this here is not an actual IA. It's just something that I wrote for myself. So I get to do that. The observed values are made up. Yes, I did not go ahead and collect data. I just threw some numbers in there. Please don't do that. Anytime that you're saying that you're going to do a hypothesis test, the first thing that you need to do is to explicitly write down the hypothesis. You can spend a little time talking about what the hypotheses are going to be, like I did here. I said one thing, then I said a different thing. But don't just not do it, okay? Then you're showing that you don't really know how to do a hypothesis test. This is always the first step, and you do need to put it there. The other thing that you need to do in the hypothesis test is to say the significance level. You have no reason not to use 0.05. Everybody uses that number. And then here's another point where I'm mentioning what technology I'm using. Like in this case, I didn't do it in Google Sheets. I put it in the TI-84. But that's it, okay? Please don't start saying how to do a chi-square test on the TI-84. That is not part of your IA. Push this button, push that button. Don't do that. Just tell the result. The P is 4.41 times 10 to the negative 8. Don't do calculator notation here. Of course, in the calculator screen, it said 4.41 E negative 8. That is a very easy thing to fix. Write it properly. And here, because this p-value was so ridiculously small, I decided to change the calculations, which is something that I had predicted from the beginning of the IA that I might do, which is to say my probability of winning is not actually 0.5, but is something that I am now calling K. And I'm going to redo all of the calculations in terms of K instead of 0.5. So all of those fractions of a half are just going to become products with either K in case of the probability of a win, or 1 minus K in the probability of a loss, which is always going to be to the power of 3 here because 3 losses in the challenge. And I just list the new results, okay? So instead of this, it's that. Don't go over doing things repetitive again that you've done before. This expression here for the new expected value looks absolutely pretty. And I do mention these things later in the text, but I want to say them now as we're looking at the expression. It is very complicated, but it is only a polynomial. It is not a complicated function. It's a complicated looking thing, which is two different things. Um, the independent variable of this function is k, which is the probability of winning. So every time that the k appears here, it's always as a polynomial. And the other things are either numbers, such as 13 choose 2. And there are other things that seem to depend on something called and here and here, which might look like it would be another variable to make this more complicated, but it's not. This n is the index of the sum, so that just means that this happens 12 times from 0 to 11, and they are the numbers from 0 to 11. So the only variable here is k, only appearing at the base of a number that is the exponent. So this is a polynomial. So I graph it here from probability equals 0 to 1. And I describe it a little bit by saying some obvious things such as it starts at 0, it's always increasing, it ends at 12. These things are obvious. And then I point out that f of 0.5 is very close to 3, which is something that we calculated before, so we should check here. And then I go ahead and take the opportunity to say some other things just to show that I know these terms about functions, okay? It starts looking almost linear, then the concavity is up, then the concavity is down, it changes at the inflection point. And then let me show that I know what an inflection point is by calculating it. It should be where the second derivative is 0. That happens at this number. Of course, I use technology for that calculation, and I mentioned that here. It wouldn't be appropriate to take the derivative of that large polynomial by hand, especially because I think it was a degree 14 polynomial. So the derivative would also be degree 13, and if I wanted to solve that equals to 0, I would need to use technology anyway, because that's not the kind of calculation that you can do by hand. So there is no point in doing that by hand. The technology is appropriate for that kind of situation. You just mentioned that you did it and what was your result. So these things I think are very natural to do when you look at that function. It falls under the category of if you don't do this, it looks like you don't care about your project. But then the next thing I did just because I went ahead and I looked at the larger domain, which doesn't make sense because k can only be between 0 and 1 because it's a probability. But polynomials can have any value of the independent variable. So I was just curious what would happen to that function elsewhere. This picture, again with technology, I calculated the turning point, the other inflection point, and I just listed the results here. Then I went back to the goodness of fit test to try it with a different number. And instead of 0.5, I chose to use the probability here coming from the observed values, losing a degree of freedom. And that number turned out to be 0.39. So then I ran the hypothesis test again, mentioning the new hypothesis, the significance level, which has stayed the same, and the new result, which was, again, very small, but I didn't expect any different from made-up data. So that's it. That's where I stopped. It is almost 12 pages. The 12th page is just this. And I was very happy with the result here, okay? I had a lot of fun doing this. It is true that I have been wanting to do this every time that I get a disappointing result in a Clash Royale challenge. This is going through the back of my mind. So I just sat down and wrote everything. And it was a lot of fun. So please let me know in the comments how you would grade me on this thing on the rubric. Okay, I've made some comments, but I didn't put a number to it. So this kind of thing can be a good exercise if you've already written your IA and you just want to improve it a little bit to maybe get an extra point here and there. It can be a good exercise to rate somebody else. So let me know how you think I did.